All right, I want to take a quick look at graphs of rational functions. We're going to use this to think about the graphs of the tangent, cotangent, secant, and cosecant. So just want to remind you, I'll take a function like y equals x over x squared minus 4. Okay. In a pre-calc 1 class, you hopefully dealt with these types of things. Rational functions mean polynomial divided by polynomial. And the thing is, if we factor top and bottom, it's going to tell us a lot about this function. So the top's already factored. The bottom I can write as an x plus 2 times x minus 2. The thing is, factors tell you where zeros are. And where the zero is, either numerator and denominator, tells you a lot about the graph of the function. For instance, a 0 in the numerator is going to make the whole fraction equal to 0. 0 divided by any number is 0. On the other hand, a 0 in the denominator is going to create an asymptote because you can't divide by 0. And when you get closer and closer, if the denominator is really small, dividing by a really small number gives you really big answers. So zeros in the numerator are going to give us x-intercepts. Zeros in the denominators give us vertical asymptotes. Right? In this way, I can take a look at this without using my calculator. I already know that at x equals 0, y equals 0. I also know that x equals negative 2 for this one. So 1, negative 2 right there. Or positive 2 out there. I've got vertical asymptotes. What happens in between? Well, there's several things I look at here. One is when x gets really big, this is an x squared over x. So if you plug in like a million, this is a million over a million squared. Well, it's essentially 0. The denominator is so much bigger, so it's positive. Everything's positive out here. So yeah, it's going to be headed down to 0 like that. And then I figure I got enough information here to draw the graph. If I work my way backwards, the next thing I run into here is an asymptote. I either have to go up to it or I need to come down. And I can argue I can't go down because I'd have to cross through the axis there. So it must go up. That asymptote was created by this factor, this x minus 2. The thing is on one side of x minus 2, so if x is a little bit bigger than 2, this is a positive number. But as soon as you drop x to the other side, where x is a little bit less than 2, then that becomes a negative number. These are still all positive, and times that negative, now suddenly the function becomes negative. So where it went up to plus infinity on one side, it comes down to minus infinity on the other side. The next thing I see is an x-intercept. I got to go right through that x-intercept. And then the next thing is an asymptote, so we either have to go up to it or come down. Well, I can't come down because I don't have an intercept in here, so it must go up. Notice where we decided here that it swapped from positive to negative because of that. It's the same thing that happens here, that when x equals 0, that was that numerator equaling 0. And when it changed from being bigger than 0 to less than 0, the whole function did as well. Right? Likewise, now I'm at this asymptote at negative 2, caused by this factor. Right? At this point, this first factor is negative because x is less than 2. The numerator is negative because x is less than 0. And now I'm going to drop to the left side of negative 2, so that'll become negative as well. And I have 3 negatives multiplied or divided together, which is going to end up being negative. And so we end up down here. And then we approach that asymptote again. Okay. The graph's going to look something like that. Right? Intercept from the numerator. Vertical asymptotes from the denominator. That's the main thing I want to pick out of this, and that's what I'm going to use in the next video when we look at tangent. But let me just point out here that if I go to my graphing calculator and actually let it tell me, I think I've got the function typed in right here already. So I'm going to go to the graph, and sure enough, I mean, I didn't have it quite that flat going through there, but the general idea of what that graph looks like. Factoring numerator and denominator tells you a lot. Zeros in the numerator, x-intercept. Zeros in the denominators, vertical asymptotes. Okay, that's what we're going to use for the tangent.